This is the key to test 3, and on problem number 1, you are asked to solve the following equation. So we have this rational equation, and I'm going to go ahead and write it on this page. So here's the rational equation. What you need to do, notice that in your denominators you have variables. So we're going to have to find the least common denominator, and we're going to use that least common denominator to clear those fractions. So when you factor, though, you got to factor. X plus 3 is prime, x minus 5 is prime, but I can factor this denominator. And when you do that, you're going to notice that those factors are the same as these right here. And so the least common denominator has to include every factor you see. So in our case, it's going to be x plus 3 times x minus 5. And before we go on to the next step in terms of multiplying both sides by the least common denominator, let's go ahead and find what the restrictions are. So the restrictions, so the values of x that makes the denominator undefined, that makes the fraction undefined, so it makes the denominator 0, would be negative 3, because negative 3 plus 3 is 0, and then 5, because 5 minus 5 is 0. And then those are the same numbers for these as well. So the restriction is that x cannot equal negative 3 or 5. So if I solve this equation and the proposed solution is one of these, then I cannot use it. Okay? All right, so let's go ahead and multiply both sides by the least common denominator. So let me go ahead and rewrite this over. So I have 5 divided by x plus 3 minus 3 divided by x minus 5 equal, and then 4 divided by, and I'm going to go ahead and use the factored part here. So x plus 3 times x minus 5. Now, we need to clear the fractions. So the whole purpose of multiplying both sides by the LCD would be to clear those fractions. So we're going to go ahead and multiply both sides by the least common denominator. So x plus 3 times x minus 5 on both sides. X plus 3 times x minus 5. And so I'm going to go ahead and distribute here to get rid of the brackets that I just put. So I have x plus 3 times x minus 5 times 5 divided by x plus 3 minus, and then x plus 3 times x minus 5 times 3 divided by x minus 5 equal, and I'm running out of room here, so I'm just go ahead and just go ahead and reduce these. So these factors divide out. So remember, the whole purpose of multiplying by the LCD is to get the denominators to be factors of 1s. And notice in this case I do, right here. So 4, this is 4, and then 4 times 1 is 4. Now, reducing this, notice this becomes a factor of 1 now. So the x plus 3's divide out, and the x minus 5's divide out. So I get 5 times x minus 5, just like this in parentheses, minus 3 times x plus 3, 3 times x plus 3, equal 4. So I went from a rational equation to a linear equation. So let's go ahead and distribute. And so I get 5x minus 25 minus 3x minus 9 equal 4. Combining like terms, 5x minus 3x is 2x. A negative 5 and a negative 9 is a negative 34 equal 4. Adding 34 to both sides, I get, combine like terms, I get 2x equal 34 and 4 is 38, and divide both sides by 2, I get x to be 18. Oops, sorry, x to be 19. So that is my proposed solution. So I look at this and I notice that it's not one of my restrictions. Assuming I did all the algebra correctly, this is the solution. So your solution is x equal 19. All right, so that's number 1. So in number 2, you're asked to find the equation of the line that contains these 2 points. And you want to write the answer in slope-intercept form. So this is number 2. Let's go ahead and look at number 2. So number 2, my 2 points are negative 2, 4, and 1, negative 2. And you want to again find the equation of the line that goes to those points, and your answer needs to be in slope-intercept form. So if I'm going to write the equation of a line, I need to know the slope. I don't know the slope. So first thing we have to do is we have to find the slope. First thing we have to do is find the slope. So the slope form, remember, is y2 minus y1 divided by x2 minus x1. So let's go ahead and call this x1, y1, x2, y2. So there's my first point, there's my second point. And so putting this back into the formula, the slope formula, we have y2, which is negative 2, subtract y1, which is 4, divided by, and then since I started with y2, I have to start with x2, so that's 1, subtract negative 2. Simplifying this, a negative 2 and a negative 4 is a negative 6. 1 subtract a negative 2 is 1 plus 2, which is 3. Reducing, I get negative 2. All right. And then I'm going to go ahead and use point-slope form. You could use point-slope form or slope-intercept form, does not matter. Remember, point-slope form is y minus y1 equals the slope times x minus x1. And so I now know the slope and I know a point of the line. In fact, I know 2, so it does not matter which one you use. So I'm going to use the first one. So I have y minus y1 is 4 equals the slope, which I just found, which is negative 2, times x minus x1, which is negative 2. Rewriting that part here to make it look a little bit better, I have y minus 4 equal negative 2 times x. X subtracting negative 2 means x plus 2. Distributing, I get y minus 4 equals negative 2x, and then minus 4. Now remember, you want to write the answer in slope-intercept form, so you have to get y by itself. So adding 4 to both sides and combining like terms, I get y equals negative 2x, because this is 0. And so there's your answer right here. So that's the answer in slope-intercept form. All right. Okay, number 3, you're given this quadratic inequality and you want to solve it. Now notice I did say in your work, make sure you show the following. You make sure you show the zeros, the number line with those zeros, the test points you used, and indicate whether the intervals are positive or negative. So here's what you have to do in number 3. So in number 3, you have to do this. So here's the quadratic inequality. You had x squared plus 7x plus 12 is less than or equal to 0. So if you're going to find the zeros, first thing you're going to do is you're going to factor this trinomial. So when you factor it, you're going to get x plus 4 times x plus 3, and again, less than or equal to 0. All right, now to find the zeros, so you got to find the zeros. To find the zeros, you want to find out where this product is 0, right? Or where this trinomial is 0. So it's always easiest to use the factored part. So to find the zeros, you're going to set that equal to 0. So x plus 4 times x plus 3 is equal to 0, and then you solve this equation. So you have two factors whose product is 0, so one of these has to be 0. So x plus 4 equals 0, x plus 3 equals 0. So my zeros are negative 4 and negative 3. So those are your zeros. Okay? Now once you find your zeros, you got to put that on the number line. So here's negative 4, put them in order, and here's negative 3. Once you put your zeros on the number line, you have to pick some test points in those intervals. So a test point in that interval is, let's say, negative 5. In this interval, there's no integer in that interval, so I'm going to have to use a decimal, so let's say negative 3.5. And in this interval, 0 is easy to use, so let's use 0. Now, you have your test points. You're going to go now, and you're going to substitute it back into this factored part. I always go back to the factored part, not the original. Just you could. Now, assuming you factored it correctly, it's always easiest to go back to the factored part. And so you're going to say, since your test point's negative 5, you're going to say, I'm going to put that here, negative 5 plus 4 times negative 5 plus 3. All right, and then looking at this factor, negative 5 plus 4 is a negative 1, so that's negative. Negative 5 plus 3 is a negative 2, that's negative. A negative times a negative is a positive, right? So that's positive. Now remember what it is so that means that any real number in that interval is going to make this product or this trinomial a positive number. But remember, you want this to be less than 0, meaning negative, or 0. Okay? So any number in here makes it positive, so that's not something I want. So I'm going to put a little x there. I don't want that. Okay, let's go to negative 3.5. So I have negative 3.5 plus 4 times negative 3.5 plus 3. Well, negative 3.5 plus 4, that's positive. That's 0.5, right? And then negative 3.5 plus 3 is negative. That's negative 0.5. A positive times a negative is a negative. So that's going to be negative here, which is something I want, because I want this product to be negative. For 0, you're going to say 0 plus 4 times 0 plus 3. 0 plus 4 is 4. That's positive. 0 plus 3 is 3. That's positive. A positive times a positive is a positive. So any number in that interval is going to make this product or this trinomial a positive number, which is something I don't want. I want negative or 0. Okay, so I know what interval makes, I know what real numbers makes this product or this trinomial negative, but let's talk about the 0. So remember the 0, the numbers that make it 0, the numbers we just found here, these numbers here, because that's how we got 0. We set that equals 0. So I'm going to put a closed circle here and a closed circle here to indicate that those zeros are included in my solution. So therefore we found the interval. This is the interval right here. So the answer is going to be bracket negative 4, comma, to negative 3 bracket. Okay, so that's the answer. All right, so that was number 3. Now let's go ahead and look at number 4. So number 4, we have this piecewise function right here. And this is an easy one, so that should have been an easy points there. So you want to find f of negative 3 and f of 5. So let's go ahead and look at that. So number 4, we have this piecewise function. And you're going to use 2x minus 3 if x is less than negative 3. You're going to use x squared plus 5 if x is between negative 3 and 5, including negative 3. And you're going to use f of x equal negative x if 5 is less than or equal to x. All right, so let's go and do part A. So part A, you want to find f of negative 3. So this is your x. You got to figure out where negative 3 is going to be located here. So notice that negative 3 is going to be this one because when x is negative 3 is less than or equal to negative 3, and at the same time, negative 3 is less than 5. So that's the one you're going to use right here. So to find f of negative 3, you're going to go to this, and where we see the variable x, you're going to substitute negative 3. So get negative 3 squared plus 5. So negative 3 squared is 9. 9 plus 5 is 14. So f of negative 3 is equal to 14. In B, you want to find f of 5. All right, so you gotta remember though that see 5 is less than or equal to x means the same thing, same as saying x is greater than or equal to 5. So if I want to find what f of 5 is, that means x is 5. So x is 5 here because that equal sign. So I'm gonna have to use this one. So f of 5 would be the opposite of x, which is 5. So the answer is negative 5. All right, so that's number 4. Number 5, you want to find the difference quotient for this quadratic function. So let's go ahead and do that here. I think I have enough room. So you want to find the difference quotient for f of x, which is negative 3x squared minus 2x plus 1. Okay, so step 1, and we can do this in steps. So remember the difference quotient is f of x plus h minus f of x divided by h. So step 1 is to find f of x plus h. So step 1, f of x plus h. So where we see the variable x, you're going to substitute x plus h. And so I get negative 3 times x plus h squared minus 2 times x plus h, and then plus 1. All right, now we got to square this x plus h. We got to square that binomial. When I do that, I get negative 3 times, and then when I square that binomial, I get x squared plus 2xh plus h squared. And then distributing here, I get minus 2x minus 2h plus 1. Now going ahead and distributing the negative 3, I get negative 3x squared. A negative 3 times 2 is a negative 6. I get negative 6xh, and then a negative 3h squared. And then writing everything else over, that is step 1, f of x plus h. So all I found was this part of the numerator. So that's this. Now what I got to do, step 2, is to now subtract f of x from what I just found. So step 2 would be to find f of x plus h minus f of x. So I just found f of x plus h, that's this. So I get I get negative 3x squared minus 6xh minus h squared minus 2x minus 2h plus 1. And then I'm subtracting f of x, which was given to us. That's this here. So minus 3x squared minus 2x plus 1. All right, so getting rid of the parentheses, this means adding the opposite or multiplying by negative 1. I get negative 3x squared minus 6xh minus 3h squared minus 2x minus 2h plus 1. And then the opposite of a negative 3x squared is a positive 3x squared. The opposite of a negative 2x is a positive 2x. And the opposite of a positive 1 is a negative 1. At this point, since I'm dealing with a polynomial, it's very easy to see this. At this point, every term that doesn't have a factor of h has to cancel out. So its opposite better be somewhere. So negative 3x squared, positive 3x squared. That's 0. That has a factor of h. That has a factor of h. This does not. Negative 2x, positive 2x. This has a factor h. This does not. Positive 1, negative 1. And what's left is going to have factors of h's. So I'm going to go ahead and rewrite this by factoring out an h, because that's going to be needed here. So to reduce. So I'm going to say h times, so when I factor out an h here, I get h times negative 6x minus 3h and then minus 2. So that's step 2. So that's your numerator. So step 3 is now to take the numerator and divide it by h. So my numerator is this. So step 3, f of x plus h minus f of x divided by h. So I just found this now. That's this. This is your step 2. The whole thing is your step 2. So h times negative 6x minus 3h minus 2 divided by h. And at this point, the h's divide out, and you have your answer. So the answer is this, negative 6x minus 3h minus 2. Okay, so that is your answer. That's the difference quotient. This is a difference quotient for this function here. Okay, so the difference quotient for, or the difference quotient of f of x, which equals to negative 3x squared minus 2x plus 1, is this, negative 6x minus 3h minus 2. And so when you take calculus or business calculus, that's going to make more sense as to what this means. All right, that was number 5. So let's look at number 6. Now, number 6, you're given two functions, f of x and g of x, and notice this notation right here, that open circle, that means composition. That does not mean multiplication. Okay, so you need to know what that means. So in number 6, you have f of x equals 5x minus 3, and g of x is 2x squared minus 6x. And you want to find f composed with g at x. Okay, so that's what you want to find. So by definition, this means f of g of x. That's what that means. So now what you got to do is you got to find this innermost one first. So you got to find g of x, which we already know. G of x is this. So in place of g of x, I'm going to substitute what g of x is. So this becomes f of 2x squared minus 6x. Kind of makes sense. G of x is this. Now I'm going to go to my function f, which is this, and wherever we see the variable, see the variable here, I'm going to substitute this expression. So I'm going to substitute this. And so therefore I get 5 times this expression, 2x squared minus 6x, and then you're going to subtract 3 from that. Distributing, I get 10x squared. 5 times 6x is a negative 30x minus 3. And there's your answer. So f composed with g at x, f composed with g of x equals this, 10x squared minus 30x minus 3. All right, so that was number 6. Okay, so let's look at number 7. So in number 7, you're also dealing with a composition in number 7, but this time it's being evaluated at a number. So let's see what we get. So let me go ahead and write this right here. I have enough room. So I'm going to go ahead and write the function. So my functions are f of x equal negative 2x squared plus 3x minus 2, and g of x equals negative 3x plus 2. And so you want to find f of g of negative 3. That's what you're going to find. So you're going to find this, f of g of negative 3. So the first thing you got to do is find g of negative 3. So let's go off to the side and find g of negative 3. So to find g of negative 3, I go to my function g, which is this one. And wherever you see the variable x, I'm going to substitute negative 3. So I get negative 3 times negative 3 plus 2. Negative 3 times negative 3 is 9. 9 plus 2 is 11. So that's this. So now I'm going to come back. I'm going to find f of 11 this time. So now I'm going to go to my function f, which is this quadratic function. And wherever you see the variable x, which I see it twice, I'm going to substitute 11. So this becomes negative 2 times 11 squared plus 3 times 11 minus 2. And so using a calculator, 11 times itself times negative 2. So 11 squared is 121 times a negative 2 will give us negative 242. And then 3 times 11 is 33, and then minus 2. So negative 242 plus 33 is negative 209. A negative 209 subtract 2 is a negative 211. So therefore, the answer, you're going to say f of g of negative 3 is equal to negative 211. So that's number 7. Okay, now let's look at number 8. So number 8, you're asked to find the inverse of this function. All right, so let's go ahead and do that one. So number 8, you have f of x is 5x squared plus 2, and x is greater than or equal to 0. So that is important because if that restriction wasn't there, then this parabola, the graph of this is a parabola, would not be 1 to 1, therefore would not have an inverse. So we have to restrict this. So that's why you see that there. So in other words, what you're looking at is something that looks like this. So x is greater than or equal to 0. So this right here is the graph of that. Okay? So notice it is 1 to 1, so it has an inverse. So we got to find it. All right, so here are the steps. Remember the steps. The first step is to replace f of x with y. So you get y equals 5x squared plus 2. Then you're going to interchange the variables. So y becomes x becomes y. So x equals 5y squared plus 2. And then now you're going to solve for y. So to solve for y, I'm going to first of all subtract 2 from both sides. So you get x minus 2 equals 5y squared. And then finally, to get y squared by itself, you're going to divide both sides by 5, just like this. 5 is reduced. And so you get y squared equal x minus 2 divided by 5. Now we got to solve for y. Okay, so we got to solve for y. So solving for y, we take the square root of both sides, but be careful you not do that plus or minus, because remember you're trying to find the inverse and you restricted the domain here. So it's no longer a parabola, it's part of a parabola. So remember so the domain here, so remember the domain becomes the range. So this is the domain of this function, so that domain becomes the range of this function. So now we're going to say y is greater than or equal to 0. So x becomes y, y becomes x, so x becomes y. So that is the range of this function. So that's why we only use, see y is positive, so that's why we don't do plus or minus, you want to do that plus. So you get y equal square root of x minus 2 divided by 5. At this point, you're going to say the inverse. So you're going to say f inverse of x is equal to this expression, the square root of x minus 2 divided by 5. And there's the answer. All right, so that's number 8. Okay, number 9, you're given the general form for the equation of a circle, and it did say complete the square. You have to complete the square. All right, you must show that. You must show that you're completing the square. All right, so let's go to number 9. So number 9, you have 3x squared minus 18x plus 3y squared plus 12y plus 24 equals 0. So before we complete the square, we got to make sure that the coefficients of x squared and y squared are 1s, and they're not. But this is an easy one because all of these numbers, all of these terms are divisible by 3. So I'm going to go ahead and divide both sides by 3. So it will then make x squared and y squared have coefficients of 1s. So I get 3x squared divided by 3 is x squared. Negative 18x divided by 3 is a negative 6x. And then I'm going to just keep on going. 3y squared divided by 3 is y squared. 12y divided by 3 is 4y. And then 24 divided by 3 is 6 equal, and then 0 divided by 3 is 0. All right, so when we're going to now have to complete the square, because I need to put this in that standard form for a circle. So which means, remember, it's x minus h squared plus y minus k squared equals r squared. So I got to go from here to here. So that's where that completing the square comes in. So let's go ahead and complete the square. So we're going to group the x's together, we're going to group the y's together, and we're going to have to bring this constant term to the other side. So I get x squared minus 6x. I'm going to have to add some number to these two terms to get it to be a binomial squared. And then I have to do the same thing with the y's. So plus y squared plus 4y plus some number, so that way I can get a binomial squared, equal, and then don't forget, you've got to bring the 6 over, so that's negative 6, and then plus whatever that number is, and then plus whatever that number is. So what you add to one side, you have to add to the other. Okay, so let's go ahead and complete the square. So remember, to complete the square, it's got to look like this. So you're going to take half the coefficient of x, so the half of negative 6 is negative 3, and you're going to square it. And when I square negative 3, I get 9, and that's what you put here, and that's what you put here. And now when you factor this, this is now a perfect square trinomial. So when you factor this, you're going to get x minus 3 squared. Now we do this one, so we're going to take half the coefficient of y. So half of 4 is 2, and then you want to square it. When I square 2, I get 4. So we're going to add 4 to both sides. And so now this should now be a perfect square trinomial. So when I factor it, I get y plus 2 squared. And now that's going to equal negative 6 plus 9 is 3, and 3 plus 4 is 7. And so that's what we get. All right, so that should be, I'm sorry, right here. I made a mistake right here. 24 divided by 3 is 8. 8, negative 8, and then negative 8 plus 9 is 1, 1 plus 4 is 5. So that should be a 5 right here. Okay? All right, so that's number 9. All right, now let's look at number 10. All right, number 10. So in number 10, you have the equation of a circle already in standard form. Okay, so let's go ahead and write that out. So here's number 10. So we have x minus 5 squared plus y minus 2 squared equal 36. And you're asked to determine the center and the radius, and you want to graph it. So the center, now remember, x minus h squared plus y minus k squared equals r squared. So where the center is hk. So it's x minus, y minus, right? So and that should be a plus right here. Okay, so x minus, so we already know the x coordinate, that's h right here, so that's 5. And then y plus 2 means the same thing as saying y minus negative 2, right? So k is negative 2. So there's your center. So the center is 5, negative 2. So remember, x minus h, so h is 5. Y minus k, y minus a negative 2, so k is negative 2. And the radius is always the square root of this. So the radius will be the square root of 36, which is 6. All right. Now we're going to use that information to graph the circle. So let's go ahead and look at a coordinate plane. Okay, so let's see. The center is 5, negative 2. So 5, negative 2 is right here. There's the center. And then I'm going to use the fact that the radius is 6 to draw a circle that should look more like a circle. So we're going to go 6 units to the right. 1, 2, 3, 4, 5, 6 right here. Let me make sure okay, so 5, negative 2, that's okay. So then we go 6 units to the right. Then we go 6 units to the left. 1, 2, 3, 4, 5, 6. 6 units down. 1, 2, 3, 4, 5, 6. And 6 units up. 1, 2, 3, 4, 5, 6. And then draw a circle. Do the best you can with drawing a circle. Make it look circular. All right, so make it look as much of a circle as possible. And so there is, of course I could have done a little bit better here, but that is the graph of this circle right here. All right, so that is number 10. Okay, all right, number 11. So in number 11, they wanted you to solve the system of equation by using the addition elimination. So always follow directions. It did not say using substitution. You must follow directions. It says using addition elimination. Okay? All right, we'll go ahead and write number 11 down. So we have 4x minus 3y equal 25, and then negative 3x plus 8y equal 10. So if I'm going to solve this system by addition elimination, I have to eliminate one of the variables. And so to eliminate one of the variables, I've got to have these coefficients being opposites. None of these are opposites. So let's go ahead and eliminate the x's. So to eliminate the x's, I got to find the least common multiple of 4 and negative 3. So the least common multiple of 4 and negative 3 is 12. So 4 goes into 12, negative 3 goes into 12. So what I'm going to do to get this to be 12 and this to be negative 12 is I'm going to multiply the first equation, both sides of the first equation, by 3, because 3 times 4 is 12x, or 3 times 4x is 12x, and the second equation by 4, both sides. What you do to the left, you do to the right. And so now I'm going to get a new system. Well, it's not really a new system. It's changed a little, but you still have the same solutions. They're equivalent. 3 times 4x is 12x. 3 times negative 3y is negative 9y equal 25 times 3 is 75. And then distributing here, I get negative 12x. And then 4 times 8y is 32y equal 40. Now at this point, these are opposites, so now I'm going to add. And when I add 12x to negative 12x is 0. This is 32 right here, 32y. All right, and so negative 9y and negative 9y and positive 32y gives us 23y, right? Equal, and then 75 plus 40 gives us 115. All right, and so now we're going to solve for y. Divide both sides by 23. And when we divide both sides by 23, 115 divided by 23 is going to be 5. So I get y to be 5. So now remember the problem asks you to write this as an ordered pair. So as an ordered pair, my y coordinate is 5. Now I've got to find the x. So let's go back to one of the original equations. So let's go back to the first one, the top equation. So we've got to solve for x. So I'm going to go back to 4x minus 3y equal 25. So in place of y, I'm going to substitute 5. So I get 4x minus 3 times 5 equal 25. So that's 4x minus 15 equal 25. Add 15 to both sides. I get 4x equal 25 plus 15 is 40. And then, yeah, that's 40. And then dividing both sides by 4, I get x to be 10. Okay, x to be 10. So that's your x coordinate. And so the solution to the system, the original problem we had, which was this right here, is 10, 5. So if you went back and you substituted 10 for x, and in place of y you substituted 5, the left side should equal 25, and then this left side should equal 10. All right, so that's number 11. So always follow directions, because it did say use addition, elimination. Okay, so let's look at number 13. So in 13 we have this. Actually 12, sorry, in 12. So here's 12. So 12, you're given a table of values, and you want to determine if the relation is 1 to 1. All right, so you got to remember that a 1 to 1 function. Now, first of all, they have to be functions, and they are. Those are both functions. But a one-to-one function is a function in which for each y coordinate there is only one x coordinate. Okay? All right, so let's look at this one. So the way I would approach this one is this way. So remember, for each y coordinate, there should be only one x coordinate. So the way I would do this is I would do this like a mapping, except I would put y first and an x, because it says for each y there should be one x. So we're going to say when y is 3, my x coordinate is -2. When y is -1, my x coordinate is 0. When y is -2, my x coordinate is 5. And then when y is 7, my x coordinate is 6. So notice that for each y there's only one x. So this is 1-to-1. Okay? In part B, this is part A. In part B, you had this table. Do the same thing. To use that idea of the mapping. Y, x, since you're talking about 1-to-1. And when y is -1, my x coordinate is -8. When y is 4, my x coordinate is 2. When y is 3, my x coordinate is 5. So far it looks like it's a 1-to-1, right? It's a 1-to-1 function. But here's the issue now. When y is -1, now don't list it again. You already have it. When y is -1, my x value is -7. So notice, when y is -1, there are two different y values. So this is not 1-to-1. Okay? Since when y equal -1, there are two different x values. Okay? All right, so that's number 12. Now, number 13, that one was easy. You just had to find the domain of the following function here, and you had to write like this. Domain is all real numbers except, and then you were told to put the values of x here. So let me go ahead and write down the function. So you have f of x equal x plus 4 divided by x squared minus 8x plus 15. So if you're going to find the domain of a rational function, notice this is a rational function. If you're going to find the domain of a rational function, you need to determine, first of all, what makes the denominator 0? What makes this rational expression undefined? So let's go ahead and set this equal to 0. So we get x squared minus 8x plus 15 equals 0. And so I'm going to factor this. And when I factor this, I get x minus 5 times x minus 3 equals 0. And I'm going to set each of those equal to 0, just like this. And so I get x to be 5 and x to be 3. So what I found were the two numbers, the two values of x that makes this function undefined. So they cannot be in this domain. So these cannot be in the domain. These are not in the domain. So the domain would be any real number except those. So where it said, right on your paper, the domain is, you'd say the domain is all real numbers except these two, 5 and 3. All right, so that was number 13. Okay, let's look at 14. So in 14, that one was easy as well. So in 14, you have these two functions, f of x and g of x, and you want to find f of -2 and g of 3. So let's go ahead and write this out. So here's 14. So f of x is -5x plus 1. G of x is x plus 4. And in part A, you want to find f of -2, and then you want to find f of 3, and you're going to add those together. So off on the side, let's figure out what f of negative 2 is. So to find f of negative 2, you're going to do function f, and where we see the variable x, you're going to substitute negative 2. That's what that says. So I get negative 5 times negative 2 plus 1. Negative 5 times negative 2 is 10. 10 plus 1 is 11. So this right here is 11. Then we got to find g of 3. So let's go ahead and figure that out. G of 3, so I'm going to go to my function g, and where we see the variable x, I'm going to substitute 3. That becomes 3 plus 4, which is 7. So this becomes 11 plus 7, which is 18. So the answer to part A is 18. For part B, you want to find, now notice this is closed circle, right? So that's multiplication, not composition, multiplication. So f times g at x. So in part B, you want to find this, f times g at x. Well, by definition, this means f of x times g of x. That's what that means. And so we know what f of x is. F of x is this linear function, and g of x is this linear function. So this becomes negative 5x plus 1, because that's f of x, but that's going to be multiplied by x plus 4. And so notice, you do have to multiply this out. So notice I'm multiplying two binomials, so I can use the FOIL method. Negative 5x times x is negative 5x squared. The outer, negative 5x times 4 is a negative 20x. The inner is a positive x. And the last, 1 times 4 is 4. Combining like terms, I get negative 5x squared. Negative 20x plus x is a negative 19x, and then plus 4. Okay, so that is f times g at x. So that would be the answer to part B. All right, so that's number 14. So let's look at 15. So in 15, we had, let's see. Okay, so in 15, you had this, and I'm going to go ahead and put that here. So there's a 15 part A. Oops, it was actually listed as part 1, part 2, part 3. So 15 part 1, 15 part 2, and then 15 part 3. Okay, so you're given this function right here. So y equals, so I'm going to write that here, y equals negative f of x minus 6 plus 3. Now that was an easy one, because notice there are three transformations occurring. There's this transformation, a reflection, a horizontal shift, and a vertical shift. So if the negative's in front of the function, that's a reflection about the x-axis. So this is a reflection about the x-axis. Okay, a horizontal shift, now remember that's where you have to think carefully about this. So this is a horizontal shift, so it's already in the form x minus, so this is your shift at positive 6. So it's a horizontal shift, shift 6 units to the right. And this is always the easy one, so that's a vertical shift, and that's intuitively easy to do. So since it's positive, you're going to go up 3. So it's a vertical shift up 3 units. All right, so then the reflection, so the answer is going to be A, so you have to say A. For part 2, horizontal shift is the one that's going to the right, so that's B. And then part 3, that's the easy one. That's the one where you're going up 3 units. So that would be, what, vertical shift up 3 units? So that's A. All right, so that's the answer to 15, A, B, A. Okay, now 16, so let's look at 16. So 16, you were given this function right here, and you want to determine if it's even, odd, or neither. All right, so here's f of x. So 2x to the 4th minus 3x squared plus 5. Now, it did say to determine algebraically, so you had to show the work. So to determine if this function is even, odd, or neither, you needed to first of all find f of negative x. So wherever you see the variable x, I'm going to substitute negative x. So you have to show this. You have to say 2 times negative x to the 4th minus 3 times negative x squared plus 5. So you have to show that. Wherever you see the variable x, you replace it with negative x. Now reducing this or simplifying this, negative x to the fourth is the same thing as x to the fourth. Negative x squared is the same thing as x squared and then plus 5. So that's f of negative x right here. Now you got to compare f of x with f of negative x. So you'll notice that f of x and f of negative x are equal. So note f of x equals f of negative x. So if those are equal, this means f of x, the original function, is an even function. If they were opposites, it would be an odd function. F of x would be an odd function. All right, so that's number 16. Number 17. Okay, so in 17, you're given a graph, the graph of a polynomial function. And you want to find out where's the function increasing and where's it decreasing. So remember, doing that, you always go from left to right. So as you go from left to right, your y values are decreasing, and then all of a sudden they're increasing. So the change is here, right, at negative 2. So in this interval from negative infinity to negative 2, your y values are decreasing. And then from negative 2, notice what your y values are doing. Your y values are increasing, and then all of a sudden they're going to decrease. So it increases up to 1. So from negative 2 to 1, your y values are increasing. And then from 1 to infinity, your y values are decreasing. And so you now take this information, you put it here. So where's the function increasing? It's increasing only in this interval from negative 2 to 1. And we'll always use open intervals here. And then it's decreasing in 2 intervals, though. Negative infinity to negative 2. Negative infinity to negative 2. Always go from left to right, smallest to largest. Union, and then 2 to infinity. All right, so that was the answer to 17. So 17 is increasing from negative 2 to 1, and it's decreasing from negative infinity to negative 2, union, and then 2 to infinity. Okay, number 18. It's the same graph, except now you want to determine where the point, and it did say the point, of the local max, local min. So remember, you get a local, see where you go from decreasing to increasing? So this low point right here is a local min. And then you're increasing, and all of a sudden you're decreasing. So this high point here, this is a local max, a local max. So in this local area right here, in this little area, this is a max, local max. In this little area here, this point is a localized, so it's a local min. And then one of the points, the local maximum is, this is 1, 3. So 1, 3. And then here, the local minimum is the point negative 2, negative 3. Negative 2, negative 3. Okay? All right, so that is 18. So 18, local max at this point, local min at this point. All right, because it did say at the point. So you have to indicate the point. All right, that's 18. And then finally, 19. 19, you're given this graph, you're given this function, and you will find the domain and range of this function. So remember, the domain is a set of x coordinates, and the range is a set of y coordinates. So when we talk about domain, we go from left to right. Notice there are no arrows. You have a closed circle and an open circle. So when I go from left to right, along the x-axis, because I'm looking at domain, I start at negative 3, because that's where this point's located, negative 3, and I end here, right? So you're going to say bracket negative 3 to 2 with parentheses because of the open circle. For the range, you go along the y-axis. So notice I start touching the graph here at negative 5, and I end at 4. So notice that's a closed circle. There's no open circle here, so that's part of my range. And so I'm going from negative 5 to 4, both brackets. Negative 5, 4, bracket. Okay, so that is that is the answer to number 19. So domain is bracket -3, parentheses 2, and the range is bracket -5 to 4 bracket. Okay, so that was, if I can get to the original page, so that was the key to test 3.